to our Statistical Performance Analytics for Agent Scoring, presented to you by Transera. Thank you for joining us. My name is Richard Guth. I'm the SVP of Marketing here at Transera. And with this, we'll begin the presentation. I have one slide at the very beginning to give you a feel who Transera is, and after that, I will pass it over to Kumaran, who are our Director of Data Science and Analytics here, who will give us the meat of the presentation that caused you to dial in and join us today. Transera is all very much focused on improving the performance of contact centers from a business perspective. And the value we bring with a company increases when they have multiple systems, multiple sites, and multiple outsourcers. But by no means does that mean that you have to fit that profile to get value out of what we have to offer. Several of our customers are single site and using systems from one vendor. To give you an example of the value we bring to our customers, one of our customers is Guthy-Renker, the direct marketing firm. You may be familiar with them with their ads, infomercials about Proactive. They have 3,000 agents, 15 outsourcers, and they handle about 18 million contacts a year. By working with us, we've been able to help them increase their sales by 10%, reduce their abandon rate by over 40%, and we save them about $1 million annually. Office Depot's Business Services Division also uses us. We support 1,000 agents with them, 10 sites, 4 continents. They manage 20 million contacts a year. As a result of working with Transera, Office Depot has been able to decrease their average speed of answer by 50%, and decrease their abandons by 59%, and we saved them $3 million annually. Wirefly has 500 agents, 3 outsourcer sites, handles about 2 million contacts a year, and as a result of working with us, we've been able to increase their sales by 5%. Their agent productivity increased by 25%, and they received a full ROI on their investment with us in less than 5 months. So you can see we're very much focused on improving the business performance, and one of the ways of our contact centers of our customers, and one of the ways we do that is with our Statistical Performance Analytics capabilities. And so with that, I will pass it over to Kumaran, who is our Director of Data Science and Analytics, who will walk through the presentation that you signed in to hear. Kumaran, take it away.
Thanks, Rick. So thanks for joining us once again. And I'm going to be talking here about the kind of best practices that we have in data analytics, specifically for scoring agents. So what is it we want to talk about today is we want to talk about what statistical performance analytics is, how do we use it for doing agent scoring, what are the various analytic approach available and how do they compare with each other, and we would finish off with a case study based on our own experience. So what is that we are trying to analyze? We are trying to analyze 2 entities here. One is the customer and the second is the agent. And we want to analyze them for 2 reasons. One is sales and the second is service. We of course have other domains like support, troubleshooting, and stuff like that where we can apply the same principles, but here we're just going to focus on these things. The customer calls to buy and the agent wants to sell, or the customer wants to cancel and the agents want to save the customer. What influences this behavior? A customer propensity is influenced by their demographic, their past behavior, and their current behavior, and also about lifestyle changes or life circumstance changes. And agent ability is determined by talent, their motivation, their experience, and their education and training. And this is not only true about agents, it is true about all human beings. Whatever work we do, we all have differential ability to perform various tasks. So this is a question we want to start out with. Let's say we have a basketball player who says his name is Jimmy, plays in the NBA. And here we have a set of data about them. And what we want you to do is read through this data you have and make an inference, or what is your confidence level that Jimmy will score 20 points in the next game based on the data you know about him.
So before I ask the polls, just notice that he scored 18 points in the last game. He averages 21 points in the last 10. He has scored between 5 and 45 points in the last 25 games. He has a career average of 25.5 points per game, and he's 37 years old. Now I will launch a poll and ask you to rate your confidence. Very high, high, medium, or low. Everyone please provide their vote. Okay, we got one person still deciding. Well, a couple. Okay, we're going to close the poll now and share the results.
So the way I would be reading through this data is the reason why we showed up here is it tells you how data lets you make decisions. So in this case, we start off with he scored 18 points in the last game, but that's just one game. Maybe he's a superstar who performed bad. He might be a bench player who had a real breakout game, but we don't know about this just by looking at the first line. Now you say he scored 21 points in the last 10 games. Okay, that is giving you some confidence. But in the third line, you look, he is varying between 4 and 45 points. He's having a lot of instability in his scoring thing. So he's going from 5 to 45. And then you say, oh, he has a career average of 25.5, has 2 MVPs. Oh, that is good. He should be like a real superstar. And then you say he's 37 years old. Now the MVPs don't count because he seems to be in his dead end of his career. So maybe that career average may not make an difference. So this is how you read the data, and as you see, the more data you have, the better it becomes your decision making. Less amount of data leads you to make wrong decisions. And we will keep referring back to this poll as we keep going on. So what is statistical performance analytics? It predicts future based on large amount of data about the past. And please note the word large amount of data. That is very important for statistical performance analytics. It leverages data science, statistics, and machine learning techniques. It analyzes data to reveal patterns and trends, variability, stability, correlation, which is how two features go hand in hand together, like how does your average handle time affect customer satisfaction? How does your queue time affect your conversion ratios? Things like that. And causation is what really caused the result. Suppose you see a result like you saw a conversion ratio of 30% for one product and 45% for other product. Why is that different? Is it because the second product is better than the first? Or maybe better agents are handling the second product than the first product? Or you have better campaigns for the second product than the first product? You have to find a reason for that. It also creates predictions from signals while eliminating noise. So when you look at the data, like in the same basketball example, the 2 MVP thing is actually a noise because it is long back in the past. And you need to eliminate noise and only look at the signals, which is more recent data. It validates predictions, and it has demonstrated successes in a lot of other fields like weather, stock, biomedical, etc. But what has been happening so far for a long time is it needed supercomputers and supercomputing techniques to be able to do that. But today you can do that with commodity hardware and commodity software with the big data technologies available to us. So what are the various stages in statistical performance analytics? The first one is descriptive, which is see what is happening. The second is exploratory, which is analyze why something is happening. The third is predictive, how do I infer what is going to happen? And experimental is how do I verify potential results and validate that my predictions are going to work. We'll jump into each of them now. Descriptive analytics is like seeing an overall picture of what is happening. It is basic segmentation and profiling. It is used for reporting. It is timeline based, like last week, last month, something like that. It measures KPI performances, and a lot of people are familiar with this. It is provides a basic level of analytics, and a lot of reporting packages do this. This is like the basic reporting any reporting system would be doing. Like in this case, By product, what is the call, sales, and conversion ratio? By week, what is the number of calls, sales, and conversion ratio? We switch to exploratory data analytics, and what we see here is we analyze why something is happening. It provides a lot more segmentation and profiling that needs to happen here. You need to find correlation between features and outcomes. And you need to find features that impact your performance. We also need to explain why something is happening. Like you see that in this particular, the top right corner, the partner 2 is performing at 13% only, well compared to other partners who are performing at 23%. And that may be because of product 4, because product 4 is where all other partners are also failing, and the partner 2 might be getting more number of calls. How do we then see that? You want to do another segmentation to see by number of calls. So you do a lot of segmentation and a lot of slicing, dicing to figure out what exactly is happening. You need to look for outliers. Outliers are like extreme cases. Like there is one agent who's showing 80% conversion while everybody is less than 40%. You need to understand outliers as to why it is happening, because the 80% case may be really true, or maybe the agent is actually gaming the system. That's also possible. So we have to research outliers to make sure that they are not bad data. And of course, you use statistics for measuring central tendency like mean, median, mode, variation like variance, standard deviation, covariation, and correlation coefficients. The best practice, of course, you need tools with which you can do EDA. Just by doing it with a simple Excel sheet won't help. And the tool should have a lot of features like segmentation and profiling features, pivot tables, advanced graphics, statistical functions, trend analysis, and it has to have the ability to handle big data. The last one is experiment. When you look at experimental analytics, what you're trying to do here is you want to validate. Once you have made your predictions, you want to validate to see whether my predictions will hold good. And that's because you don't want to risk things in production. You want to put something in production and see something fail. You want to know beforehand, if I do this, what would be the benefits? What would be the side effects of things? So what you do in experimental analytics is things like you do benefit analysis, like what would be my dollar increase in terms of revenue? You can compare different models or different systems you want to use. You can do A/B testing to see how one compares against other. You can do impact analysis, like suppose I change my staffing in a different way. How is it going to affect occupancy? How is it going to affect my average entry time? How is it going to affect my average speed of answer? And you can do what-if analysis like these, and simulation definitely helps a lot because it helps in understanding the side effects of changing one variable and seeing how other variables react to it. Predictive analytics is predicting what would happen in the future. It produces scores that predict how a given segment, when I say segment, it is like an agent or a team would perform. It uses the features that show causation. When I say features, there are a lot of features available like, average handle time, conversion ratio, or the agent skill levels and stuff like that. But you want to use features that actually would result in an outcome. Adjust for impact of other features. Of course, any outcome you see can be impacted by a lot of things, features, and you want to make sure that you want to isolate this feature's outcome from the others. Of course, today there are multiple scoring models in use, and there are a lot of significant opportunities to use statistics and machine learning here. And this predictive analytics is the section we are going to delve in deeper in the future sections of this presentation. So here you have a poll question 2. You are to hire an employee, but you can't interview them. You are asked to just hire. So you see two candidates, Ross and Ryan. Ross worked with you for 5 years, and you know he's a great fit. Ryan has kind of the same credentials, but you don't know him. Who will you hire? This is kind of a stupid question, but there is a reason we are asking this question.
So now we will launch the poll and encourage you all to vote which one you think we should be hiring. Okay, we got a few more still voting. Okay, so I think we've got it. So we're going to close the poll now. I will share the results.
And as expected, everybody voted for Ross. And the reason is you know him. But let's get a little deep into what your decision-making process was. You picked Ross because you know more about him. You have more data about him. You have a lot more data about Ross than you have about Ryan. And that is exactly why you picked him, even though that is kind of, not really, it's very an involuntary decision. That is what is happening inside your mind. You know a lot about Ross, and a lot of the data looks good, and that's why you picked him. And that's what we want to highlight here. So the next best practice is we're looking at what kind of data do you need to do all this analysis. You need a large corpus of data. Few observations hardly tell the story. And as you have seen in the basketball example, looking at just one score at the last two scores is not going to help. You need to have like scores for the last 30, 60 matches. Should be large enough to avoid noise and seasonal variations, but it should be recent enough to avoid staleness. Again, the 2 MVP thing, it's in the last, it is like 10 years back, so it doesn't make any sense here. Data about interactions and their outcome need to be integrated into one logical record. Why? That's how you can analyze it pretty easily. And you got to integrate data from IVR, ACD, quality management, WFM, and CRM. And this helps us to analyze what the customer did, what the agent did, and what the outcome was. IVR tells you what the customer's intent was. ACD tells you what was the queue time, handle time, things like that. QM tells you how well the agent performed. The CRM is going to tell you the outcome of the particular call, and you got to link them together to get the whole picture, the whole 360-degree picture. If you have enough examples to predict their performance, more data is always better than more algorithms. This is like a standing mantra in the field of data science. More data is always better than more algorithms. At least 600 samples are known to give stable predictions in terms of agent performance, and that is what we have seen in our experiments on doing projects with other customers. Best practice for data integration, as we said, we want to link all of them, but it's got a lot of challenges, and that is because the data is spread across so many applications, and these applications come in various forms. Today you have homegrown applications, enterprise applications you buy from others, you use some cloud-based applications, and trying to get them all together into one single straight record is going to require a lot of hardware, software, applications, consulting. You are limited by your technologies, your data storage capabilities. It definitely needs big data adoption. And this is where big data helps. Big data infrastructure like Hadoop, HBase, H2 for in-memory, and there's a lot of other technologies there. And people are using these technologies to link data the way it has been explained here. And you can create one normalized flat record using for an interaction from multiple systems. And you need ETL engines for data acquisition and ingestion. And you need interactive big data analytics tools. That's not an easy thing, having interactive analytics with big data. So those are the challenges you actually have today with data integration. Now we move on to how we can use SPA for agent scoring. SPA for agent scoring is about analyze how agents perform their tasks, differentiate agents by ability, identify opportunities to utilize this differentiation to improve your business goals. Use your best agent for the job as much as possible to improve outcomes. If your agents are good in sales, use them for sales. If your agents are good in support, use them for support. And you can do better routing and distribution. And it helps you manage your agent pool because you can identify and nurture your best agents. And of course, you can prune non-performing agents or vendors. The value of a performance-based score is that it is directly related to its outcomes. Outcomes like conversions, retentions, and CSAT. So if you look at things like a quality management score, it might be an indicator of how well the agent is doing, but what the business is focused on is the outcome, the results, the effectiveness. And a performance-based score gives you that. Business outcomes are determined by agent skills, and agent skills lead to better outcomes. And an agent's ability to engage and sell, their product knowledge, and their perseverance that they can show in the job in order to sell. I mean, there are certain attributes that make a better salesperson. And One of the best practices you need here is that, again, we want to repeat, you need more amount of data for a given routing application. You need data for a similar kind of activity. When I say similar, the same agent is handling like both sales and support, and you want to first look at the domain being the same, like about how is this guy doing with respect to sales, and within that you need 600 samples. Contact centers, of course, experience regular and significant churn of agents. This has been a long program, and typically 30% of the agents leave in 3 months. And that is the level of churn you have. And if an agent takes like 20 calls, how long does it take you to get 600 such samples? And it's a long time. And of course, you move agents around campaigns, you move agents around applications. So obviously, every time you do that, your counter is getting reset. And agent scoring need to adapt and score agents who do not have enough sample size. You can always take a stand and say, you know what, I'm going to put them at the top of the pile or at the bottom of the pile and wait until they have enough samples. But what happens then if you put somebody at the top of the file and he's performing badly? What happens when you put somebody at the bottom of the pile and they do a good job, but you're not moving them up or giving them more opportunity? You have problems with an agent motivation and stuff like that. So this is an example of how agent stability looks like. So this is cumulative conversion ratio for a given agent, where we progressively increase the number of calls and see how they perform for the given agent. And this is for about 6 agents, and you see how they perform as the number of calls increases. Initially, you see a lot of jitter, and that is what we call statistical noise because you do not have enough samples. But as the number of calls increases, they start to stabilize. And around 200 calls, what you see is they are really stable. They are almost in a straight line. And more importantly, they have separated themselves from one another. And that kind of shows how they have differential abilities to do conversions. And this is what is important for us to utilize in our agent performance model. For question 3, you are to hire an employee, but you can't interview them. Same condition. You have 2 candidates, again Ross and Brian, but you don't know either. But what you know is Brian has an MBA from an Ivy school, and Ross has an MBA from a city college. Just using this information, you need to make a decision on who you will hire.
Okay, so with that, we will launch the third and final poll. Which one are you going to hire, Brian or Ross? Some people are still deciding. And there we go. We're going to close the polls, and we will share the results.
So in this case, it is not an easy decision to make because you don't know either, and all you know is that the school they came from. So one of the factors that you will factor in making the decision is if somebody came from a school, they might be better than the other school. In other words, you are trying to rate the individual person based on the school in which they study. What that means is you are taking the average score of all the students who came out of a given school and attributing that to an individual and saying this guy is going to perform at the average level of all the candidates who came out of that school. And that is what we call population-based scoring. And we will hear more about this as we go on in this presentation.
Well, it's interesting, Kumaran, you'll notice that it was pretty split. So clearly people picked the college of preference based upon their job requirements.
Yes.
It's not always going to be one or the other.
And this is a tough problem, and that is the problem that a lot of contact centers are facing. And that's why we come up here and say, and we have a best practice here, which is you need to blend an individual and a population score to get the right agent score. That's because agents don't stay enough for a long time to get enough data about them because attrition, new agents, hiring and firing. So in that case, what you do is you have a blended score where there is a weightage for the individual agent's performance and there is a weightage for the population score. So when a new agent comes in, he doesn't have any calls, you just give him the population score. So there's 100% weightage for the population. But as the individual agent starts building more samples about his own performance, you start increasing the weightage for the individual score in the overall score and keep decreasing the population's weightage in the overall score. And the graphic below shows you how that will vary. And we have seen this to work really well, and we will show some results on this too. This shows the scoring and ranking process overall, and what we want to stress here is two things. One is this is a continuous process, and second, it needs to be automated. Continuous because your environments keep changing, your campaigns keep changing, your product mix is changing, your business is changing, agent pools are changing, how your route calls are changing. So you have to keep adapting to them, and you have to keep rescoring them again and again. It's not a one-time job. And because it's not a one-time job, it is better for you to do it in an automated way, do it through software rather than through physical people sitting and doing it. Next, we go to experimental simulation, and why this is a recommended thing for you to do an experimental simulation. If you have a simulator, that is great. If you can do some simulation with maybe some mathematical simulation, that's also good. But ideally, when you have a simulator, what it should simulate call arrivals. It should simulate agent staffing, and it should simulate how you want to route and distribute. It should calibrate itself against the actual data. So how do you test the simulator is take actual data from your ACD or something like that, give it the same call arrival rates and the same agent staffing and the same routing, and should come up with the same kind of results. That's what the calibration means. You should measure the impact of changing. It can help you measure the impact of changing one variable on others, which we talked about earlier. How does a new staffing model works on ASA? How does a new routing model works on abandon rates? And it helps us validate the expected benefits can be achieved before deploying it in production. That's a very key thing, because it helps you yourself validate, okay, I'm making an assumption here. I'm thinking this is going to work, but will it actually work? Or does it have some side effects I don't know about? And you can use this to validate that and present the results to your management, and they would be a lot more confident in looking at this before saying, let's go ahead or let's abandon this particular task. Now I'm moving on to the various analytical approaches that are available and how do they compare against each other. So an example I want to point out here is if you guys are following the World Cup soccer these days, you would have already seen Spain, which has been the last champion and which has been performing very well in the last few years, had a very bad game, and now people are having knee-jerk reactions as to, okay, those guys are done. And some people are saying, no, it's just a one game failure. You should not bother about it and keep going on. So what do you do about it? The reason why I'm highlighting is this is the kind of thing we do today in contact centers also. And the scoring model approaches kind of reflect that. So we'll start with what are the best practice. As a best practice, what is a good scoring model? A good scoring model should have minimum prediction error. It should have used large amount of data to provide stability. It should have recent data and avoid stale data, and it should be able to model new agents in a proper way. It should be adaptive to changes. You should be able to recompute pretty frequently to observe business changes and change course for new agents as more and more data becomes available to them. You should keep agents motivated. It should reduce tenured agents' frustration of constantly fluctuating scores, as well as it should keep new agents motivated by giving them better opportunities as they keep showing performance. The first thing that the first scoring model is attribute-based scoring, which people also have been using a lot, which is you use agent attributes like education, languages, etc., they know, etc., to create skill profiles. You say, okay, this guy has so much education, so much experience, and maybe this guy is top one, first category. This guy is the second category, third category. And then use those skill profiles to do your call distribution. The good thing about it is it's pretty easy to do, easy to score, easy to configure. You can just do it in an Excel sheet. There are no data collection headaches, no data integration headaches, and scores won't change over time. But the issue is it is not performance-based. It is not aligned with your business. There is no fine-tuning of distribution to maximize your returns. Finally, there's no motivation for the agents to perform better. Because the agent always has the same score, and he's going to happily sit there knowing that his score is going to stay, and the score is not going to be affected by his performance. The second scoring model you use is a short-term scoring model. It uses data for a very short period, like last 15 days or so, to measure performance. Use that past performance as the score for the agent, and then use it to preferentially route calls to the available agents. The good thing about this model is it is performance-based scoring. New agent data becomes very quickly because once the agent has 15 days, works for 15 days, he has data for him. And it only requires small amount of data, which also means small amount of displays, processing requirements and stuff like that. The bad thing about it is it lacks enough samples, which will lead to high statistical errors. If you refer back to the other chart we showed you, when you have less number of samples, there is so much of jitter that is happening. The people are just all over the place. What that does is it creates agent's frustration because the agent score is going to be constantly changing. And there is no credit for long-term performance. I would say this model is almost like if your boss is doing your appraisal weekly. What will happen? You're getting appraised every week your salary is getting adjusted. You are going to be in a really frustrated mode, in a tense mode. You're not going to focus on your job. The appraisal is going to be constantly on your back, and finally you will quit the job. And that's what will happen in these models. Long-term scoring model is a better model. Use data for a longer period to measure performance and use that performance to do preferential routing. Good thing about it is performance-based scoring. It uses stable scores for agent, won't change week to week, and there is credit for long-term performance. But you have data collection scaling issues. New agents take time to get scores, and there is no dynamic adjustment for new agent scores. That is a big problem. New agents come in and they will get frustrated because even though they are doing a good job, they are not getting better scores, they are not getting more calls. It would lead to a lot of frustration among those agents. The last technique we talk about, the preferred technique, is the statistical analytics, using statistical analytics for agent scoring, where it is a blended agent score and it is computed based on the individual agent's long-term performance and the average score of the agent population. We also saw earlier how we want to blend as the number of calls go in. One is start increasing the weightage of one and decreasing the weightage of the other. It uses long-term data for stability. It gives scores to new agents. A new agent score adjusts dynamically as more data about the agent becomes available. It uses statistical and machine learning techniques to blend agent score and population scores and also to rank the agents. This is how the models compare. This is an example. We took it from our own work with other customers. So what you see here is we are trying to compare 4 different scoring models. You are having the Transera score in orange. There's the long-term conversion ratio, the short-term conversion ratio, and the moving average conversion ratio. And we are trying to see what is the prediction error, which is how will the actual performance different from the predicted performance, and see how they vary across these models. We are actually having 4 clusters of bars here, and that is by the number of agents, number of calls each agent took. The first set of bars are for agents who only had like less than 100 calls when we were scoring. These are mostly new agents. Then the second set of things you see is 100 to 300, third is 300 to 600, and then you have greater than 600. And what you see is when the agents don't have enough number of calls, which are basically new agents, there's a lot of prediction error with respect to the long-term scoring models, but there is very less error with respect to using Transera scoring model. But as the number of samples increase, all of them kind of settle down to be of equal performance. But the bad news is here. What percentage of agents fall into each of these buckets? 25% of the agents have less than 100 calls. 35% of the agents had from 100 to 300 calls. We are talking about having 600 calls as the true sample size, and 60% of your agents have less than half of that. So that is where the blended scoring model comes into play, which gives you accurate predictions when you do not have enough samples. And that is why we have seen our scoring model doing a lot better, and we are able to predict and achieve the same performance for the various agents, which we will see in the case study. So now we move on to the case study. The case study is about a leading direct-to-market company which had multiple channels, products, and partners. Their goal for this case study was how can they use the data about their agents to improve their business. How can they improve their revenues, their conversions, and stuff like that. So what we did is we collected and connected the data. That's 3 months of data. That's about 5 million interactions. We got the ACD data, the CRM data, and linked them together. We put them into our big data repository. We analyzed them for insights. We did an exploratory data analysis, and then we did predictive modeling. Then we did scoring based on our Transera scoring model, which is the blended scoring model. We divided them into 10 performance groups. And then we had recommendations. We had recommendations for a route from a routing perspective to do preferential routing, which is whenever a call comes in, among the set of agents available, send the calls to the agents with the best score. And the expectation is the more number of calls you send to the best performing agents, it is going to increase your overall conversions. We will see results in the next slide. And we are able to achieve about 14% conversion improvement over the previous longest available agent routing they had. That is 14% increase in their revenues. The next slide here shows some results. Let's take some time to understand the table here. The first column shows ranks, the rank of the agents, which is nothing but the predicted score of the agent. The predicted score of the agent is what is used to determine the rank. And based on these ranks, we did performance-based routing. The next 4 columns.
Kumaran, is 10 high or is 10 low?
So 10 is high and 1 is low.
Okay.
It's in descending order.
So the best agents are in the 10 group.
Yes. So the next 4 columns show how they performed, the actual performance. The first column shows occupancy, and you see the occupancy is in declining order, and that is because every time a 10 agent is available, you're sending calls to him preferentially. So obviously their occupancies are going to be very high on the top, and it declines as we get to the bottom. The second and third columns are calls and orders, and the fourth column is the conversion ratio. Conversion ratio shows the actual performance. The rank shows the predicted performance. And as you can see, the conversion ratio is tracking with the ranks. Higher ranked agents continue to convert at a higher ratio. The lower performing agents continue to convert at a lower ratio. And this is where we see that our Transera agent score is able to predict accurately what your future performance is. And in order to validate, in order to measure how much lift we have, we used our simulator. And how did we use the simulator? We used the same data, passed it to our simulator, same call arrivals and same agent staffing, but we used a longest available agent algorithm to see how the calls will distribute. So in a longest available agent algorithm, what is going to happen is every agent gets an equal chance. It's a round robin thing going on. So the occupancy is going to be the same across all agents. And we are going to redistribute the calls here. So we are going to take calls from the lower performing agents, from the higher performing agents and give it to the lower performing agents in LAA because it's equal distribution, and the distribution is simply based on occupancy. The last 2 sections, the last difference shows you the differential number of calls and orders. So let's look at rank 10. Rank 10 took only 254 calls in LAA, but it took 696 calls in performance-based routing. That is because in performance-based routing, we took calls from the lower ranked agents and gave it to the higher ranked agents. And because of that, they converted. And given that their conversion ratios are higher, they convert more than the lower performing agents. So this you see positive and negative values for both calls and orders. But the net is you got 525 more orders when you are using scorecard routing. That is about 14% improvement over the earlier number of 3839. And this is how you see that the blended agent score based on statistical performance analytics is able to predict the future accurately, and we can use experimental analytics to measure your conversions and improvements.
Great, thank you, Kumaran. An excellent presentation. Now, before we go to the Q&A session, I'd just like to take a couple of minutes to walk you through the technology that Transera uses behind this. This is a 60-second advertisement for Transera before we have an open Q&A session with Kumaran. The way we here at Transera perform statistical performance analytics is that we have a SaaS-based customer engagement repository and an analyzer visualization product and analytics product that sits on top of that. And in addition, Kumaran and his team provide a analytics as a service where they provide advice and recommendations and help our customers go through this process. So at a very high level, what we do with our customers is we work with them to gather the data from their various data sources, which we then put into our repository, which is already set up to accept data from various contact center systems. It knows what fields to expect, so it's a very quick mapping process. So we can create these flat records that Kumaran talked about in his presentation. Once the data in the repository is all collected and connected, we then make an analyzer product available to our customers, and Kumaran and his team walk our customers through the process of using it and doing descriptive and exploratory analytics where they segment, profile, and visualize the data in there to look for what's causing the business outcomes you want. What are the agent behaviors? What are the scripts? What are the customer behaviors that are driving the business outcomes you want from your customer interactions? Once we have those hypotheses as to what's driving the business outcomes, this is when Kumaran's team kicks in with their analytics workbench, which they use behind the scenes to do some scoring, validation, simulation, and do the predictive and prescriptive analytics to make sure that before you implement any changes in your existing systems, you know what the ROI is going to be. And then we work with our customers to automate the improvements so that we actually change the way the systems behave. We drive their behavior in a data-driven, analytics-driven fashion that drives what the next best action is, routes the customer to the most appropriate agent, makes the best offer, sets up the agent with the right script. And so with those next best action recommendations, we then feed that into the various contact center systems and drive their behavior. So that's a very high level of what we do. And with that, I'd like to start to go into a Q&A session. We got quite a few questions here. So let me pick out a couple. The first one is, let's see, here's one for Kumaran. Kumaran, great presentation. But how long does it take to do the process when your team gets engaged, and how long before we can see results? It sounds like it's a many-year statistical analytics process.
We already have all the tools and technologies that we need, and we have tools and automated processes that are built in. So once we start getting the data that we need, it's about uploading into our repository and running our automated analytics process and coming up with the results. It's a few weeks of work. It's not like a few months of work for sure.
Okay. Well, here's actually a good follow-on, Kumaran. How many data sources do you need to combine data from to get valuable insights?
Minimum of 2, at least the ACD and the CRM systems. But if we can add the IVR system and the quality management system, that would be great too.
Okay. Here's one that comes up more than once. We currently have a voice of the customer initiative going on with speech analytics. Does this replace our speech analytics process?
It is actually complementary. So if you need to have a look, there is a difference between when you say look at a performance and how, let's say you are trying to evaluate a salesperson. Now you can evaluate a salesperson by how he talks, how he presents some things and stuff like that. That is what a quality management system does. And you can evaluate a salesperson based on what sales he brings in. That is what performance-based modeling does. You can use them both. They are complementary, but performance-based thing is definitely better because you are more aligned with the business. A lot of cases, you use quality management as to measure your agents because the performance measures are not available. But performance measures are available, yes, you want to use that. You want to use quality management for things like customer queries, things like that, where there is no real outcome like a conversion ratio or a retention ratio you can measure. But wherever you have that, use it, is my recommendation.
Okay, here's one. Kumaran, I run the sales portion of our contact center, but we don't have a large IT team supporting us. How much will IT need to be involved in order for us to do this kind of analytics?
To start with, it is minimal. The way they're going to help us is giving data feeds if you have, enterprise system deployed inside your company. But if you have a data in the cloud, like you're using Salesforce or cloud-based WFM applications, we already have connectors for this. All you need is connection information like a username, password, and we would be able to extract data out of them and start using them.
Okay, great. Okay, we've got almost into the hour, so we've got time for one more question. I'm going to take this one. It's, what do we have to do to get started with you? Well, first off, I recommend you email analytics@transerainc.com or call our 800 number. And what we will do is do an initial evaluation over the phone with you to understand what you're trying to accomplish. And the way we get started with most of our customers is they provide us 3 months of data from 2 of their data sources. They provide us a CSV file from their ACD or whatever is managing their calls, and then 3 months of data from their CRM or their order entry system, wherever the business outcome of the calls is occurring. And we then go through a process to bring those together for you, put them in the repository, and we do an initial analysis to give you a feel for what the benefit might be if we take the process further. And then once we understand the scale of the process, then we can start talking about process and the revenue and the dollars involved with that. Though we say it on our website, we believe in ourselves and our ability to bring value enough that we are willing to share the upside with you and lower the cost up front to get you started. So minimal risk on your side to take step 1. So thank you very much. Please feel free to email us or call with any questions, and we greatly appreciate your attendance of the webinar today. And thank you to Kumaran for giving us his valuable time and giving us a very valuable presentation. Thank you.
Thank you, Ash.